Hello everyone, this video I will show you our new product. This we called KC868 AIO. That means all-in-one. This is all-in-one resource of the ESP32. So this controller is the most powerful ESP32 board. We have integrated the analog input, analog output, and digital input and digital output all in one this box. And this box we have designed with this metal box, just as similar as the H32B Pro and KC868 server. So this is very stable and the beautiful black box. And this box also will support the Home Assistant by the ESPHome. And also you can write your own code about the Arduino code to drive all this hardware resource. And in this video, I will show you this PCB design details, the hardware details, and how it works with the Home Assistant and with the Arduino IDE. Okay, let's begin. Okay, let's look at this KC868 AIO. So this is a metal box and the black color. You can see this is the metal, and this is for many input channel and the Ethernet part. And this box also supports install on your DIN rail, and this is the Wi-Fi antenna or 4G module antenna. You can install from this hole, and also you can install from this side. Also have many holes for you to use. And if you have installed into your power distribution box, you can see here that can support install on the DIN rail, just like this. This will be installed on your power distribution box. Okay, this is the box, and let's look at the PCB board. We will easy to see the hardware details. This is the box. Open this box, you will see this PCB board. So you can see that is AIO, and in front, and this is the back, and this is the back side. And we can remove this board. So you can see here there are many digital input. There are totally have 58 digital input, and analog output, 16 channel analog output, and 19 channel analog input. And also you can see there are many different terminals on this side. And this is for the output. That is MOSFET output. Totally have 32 channel output. And this you can see that is for DC power supply. So this board will support 12 or 24 volt. You can see here that is DC power supply. And these two GPIOs are for sensor, for temperature sensor or humidity sensor, integrate Home Assistant by ESPHome. And this RS485 communication cable A and B. And this is a 3 volt for power supply for the sensor, such as DS3231 temperature sensor. And this is 2 buttons that for ESP32 reset and for GPIO 0 defined by yourself. And this is Type C USB for download and monitoring and debug for your board. And this board will also designed by the ESP32 module, but that will have an IPX socket, so you can extend your Wi-Fi antenna from this socket. And this board is for analog output. That is for 16 channel analog output. That is LED indicate. So if you want to use analog output, you just connect this module to this socket. Actually, this board will include with this black board. And this is option for the module. So let's look at this clearly. So this is for I2C RTC module. And here we can see that is the socket also is removable. The output is removable. And all this input also is removable. So you can see I can remove this socket. And this is not without screw. So you can connect with your one, just use this way to fix. So you can see we have designed this board. You can use by the 2 different sockets. You can see here that is without screw, and this is by the screw. So if you want use this type of socket, so you can remove it. You can see this is screw version. So also you can connect with it. Just the default configuration, we will use this socket. Okay, let's look at our phone. So this have AIO. So you can see here that have many results of the AIO board. And here you can see the hardware details from the datasheet PDF. You can see here just this file. That is Kinkoney AIO, that all-in-one board. So you can see the ESP32 and different module, and the hardware details. There are so many different dry contact input, 36 channel, and also you can see there are 2 buttons for you to use. You can define your function by your code or by your setting. And this is analog output, that is DC 0 to 10 watts, and the analog input both support 0 to 5 sensors and 4 to 20 milliampere sensors. So I think almost support everything type of the sensor. And this is the output. The output, you can see that is the MOSFET output, 32 channel. So you can work with a 12 DC or 24 DC, and with this external relay module K868 E16. So you can control many different DC load, such as the sun and the door lock and the void, and some different contact, just the DC load. So you can connect directly. And this is the hardware. And also we can see this is our PCB design, that is all-in-one. We have designed this, the newest is 1.4 version, because we have designed this board up. It takes about 6 months, so have many different board have feature, and at last we have successful at the 1.4. So you can see we can build this board in 3D, and this is in front of the board. We can see this in front and this back front. Okay, and we can change to 2D mode, and this is the hardware. And the hardware, you can see here the pin define, every pin of the ESP32, how to use and how to configure. You can, from these files, you can see there are every chip and I2C for extend the GPIOs and analog extend, you all have at here. Okay, now let's look at how to integrate to the Home Assistant. You can see this is our Home Assistant YAML file. So this is the Home Assistant I have integrated. You can see the output, analog and analog input and digital input and output and the DS18B20 temperature sensor. Now let's look at this AIO board integrated to Home Assistant. I have connected with this terminal, and with this power supply, 12 watts will connect it. And this is temperature sensor, DS18B20. I have connected with the GPIO. So I can remove this socket and connect with the new socket I have connected with one. So every 8 channel output, there are VIN that for power supply. Because we designed for independently, so you can let every 8 channel have a different volt of the VIN. So maybe this you have connected 12 watt, and this we have connected 24 watt. So the different 8 channel will output a different voltage of the power. So you can see here, now I have just a test with the 12 watts. So I have connected all this VIN together. And this is the power supply, and this is the temperature sensor. Okay. And we have used the Ethernet cable connect with it. And before I power on, I will open this metal box, and I will let you see how it works. We can open this box. Because I have installed all the modules, you can see here the 4G module, that have installed the SIM card at here, so that you can use the GPS or use the short message for remote control your output or read the sensor state, that is output. And this is LED indicate for 32 channel output. This is 16 channel output, that is for the LED indicate, have 16 channel LED indicate for different value. And this is the RTC module, that is DS32 and 31. So this, if you have installed the battery, so you can save the clock of the system, because the board will send by the AirPlay, so we can't install the battery on this socket. Okay, now you can see this is hardware details. We will begin power on, and you can see power on. The red LED is on, the LED is on, LED is on. Okay, let's look at the home assistant. You can see here, that is the AIO I have created. Actually, you just click the ESPHome, so you can very easily to integrate to home assistant by ESPHome. And there are many ESP32 Kinkonny board, so I can see that is the AIO. So you just edit this AIO and copy this config YAML file from our Kinkonny form. So just this file, you can see the content. So you just copy and paste, is very easy. And maybe you need to change your static IP address, but I have used if you have used the DHCP, that will be good. This is static IP address of my board. So you just install and connect to USB cable and to your Raspberry Pi or to your KC868 server. That our Raspberry Pi server just downloaded by USB cable, is very easy. And after complete, you can see there are our dashboard I have created in 14th floor. You can see that is digital output, 32 channel output, but this are LDD7 and LDD8. There are two LEDs we have designed for you to use for some different functions. So you can see if I have turned on all 32 channel, you can see here and here. So this is output 1 to 32 channel. And you can see here that D7 and D8, so you can see here, I can turn on and turn off. So this is just a LED. So there are two LED for you to use. So maybe you have some different functions you can define. That will be easy to see the LED indicate from outside the box. So you can see here. And this is the DS18B20 temperature sensor. So you can see here the temperature, and you can change this temperature sensor to your humidity sensor or other 1 watt sensors. Just it's up to you. So this have set the update time. So I have set about 16 seconds. So this will be long. And here you can see that is analog input. This is all analog input. We can see here this PDF file. You can see this is analog input from this 1 to 8 and 9 to 6, because this is for 0 to 5 volt, and this 9 until 16 channel is for 4 to 20 milliampere. So it's used for different sensors. So you can see if I have tested, this is analog 1. So this is analog 1. You can see now I just test. You can see this is 3 volts at here. I just short for this, and you can see the voltage is changed. This is channel 1. This is channel 1. So you can connect with the different sensors to monitor the data, because you need to configure the ESPHome for the different range. So this you can see AI1 to AI16, but you can see there are 17, 18, and 19, because this is 3 GPIOs from this ESP32 directly. And this 16 channel analog that have a extended chip. So These all have connected the analog input 1. Because you can see this is a chip, it's an I2C chip, will let you analog input 1 and extend to 16 channel. So this chip, the function, makes the ESP32 have so many different analog input. Okay, this you can see, that is the analog input. You can also set the update time. You can see here, that is analog input, different analog input, just update interval. You can set this time. This I have set to the 5 seconds, you can set to other seconds. So this is for analog input. And here you can see that is the analog output that used for the dimmer or your LED strip. So you can see have 16 channel analog output. If you can turn on, you can see here, as the LED indicate, you will see that is become on is slowly, and when I turn off, you can see that is off. Let's look at clearly. You can see here that is 16 channel analog output. So the different voltage, the LED will have different light. So you can see I can turn on all 16 channel. That will be on just slowly. And turn off, that will be off. So if you can see, I can turn on this first dimmer. You can see I can change 50%. You can see the LED, let's clearly. You can see I can change to 100%. That will be very light, and reduce, and reduce. You can see the LED will be change the brightness. So every channel you can use the dimmer. You can see this is number 2 and number 2, and this is 100%. And so you can see here, you can see here the PDF file. That is the analog output. This socket, just this socket is analog output. So if you turn on the channel 1 and channel 2 to 100%, so this 2 terminal will output DC 10 volts. If you turn off this LED, you can see if I can turn off and turn off, so this terminal will output 0 volt. So this will be different brightness, will have the different voltage output. So this is just the analog output. And then let's look at this digital input. So you can see here this digital input 1 and until digital 56, but also have 57 and 58. So until this is 56, but there are two buttons. That is 57 and 58. So you can see, if I can short for this terminal, this is ground, and this is channel 1. So let's look at this home assistant. You can see here, I have short for this. This is channel 1. You can see that will be on, that is triangle. And the short for this with ground, that is input 2, is short. So you can see here, we can see the last digital input, S3 and S4. So you can press this button. You can see this S1, S3. When I press this button, that will be on. And this S4 also is on and off by this button. So you can define these two buttons, just a short way for you to create some automation. And these two LEDs and these two switches can use by yourself in Home Assistant. Okay, this we have designed these two buttons and two LED for you to use. And this is the Home Assistant dashboard. Okay, let's look at the form. you can see not only the home assistant is supported by this AIO, but also we can use this AIO board for Arduino IDE very easily. You can see here we have prepared some Arduino demo source code for different hardware resource, such as you can use it for the digital input. So this how to use the digital input, read the sensor states, and how to control this output for on and off. So I'll have this Arduino IDE source code. You just download this code. You can see this code. You can just download and directly to use. That is the zip file. Have include the INO file. So you can easily use any resource in your Arduino IDE. Okay, this is how to use this AIO board and integrate to your home assistant and make your home automation DIY. Thanks for watching.